Hello everyone, and welcome back to Mitchell's Physics Review. Today we're working on gravitation. Let's look at our problem. Plaskett's binary system consists of two stars that revolve in a circular orbit around the center of mass midway between them. This statement implies that the masses of the two stars are equal. Assume the orbital speed of each star is absolute value of the velocity is 160 kilometers per second, which means their magnitude is the same but the direction is different. And the orbital period of each is 14.9 days. Find the mass m of each star. And then, as a little side note, it says, for comparison, the mass of our sun is 1.99 times 10 to the 30th kilograms, which will come in later for our conversion to solar masses. First, let's look at this with just forces. So, since there's no other force acting on the stars but the force of gravity, we know that there should only be a single force pointing towards the center because, since this is a circular orbit, we know that they are accelerating centripetally, which means the force making it accelerate must be pointing towards the center. Likewise, since it's a circular orbit, the velocity must be pointing tangent to the point of the object on the circle. So, now we can look at our givens. First, our givens for this problem are the velocity and the period. For the period, we're given 14.9 days. But we should start by converting that to make our lives a little easier later. So, by saying 1 day is 86,400 seconds, we can convert the period to 1,287,360 seconds. Next, for velocity, we can convert 160 kilometers per second to 160,000 meters per second. But in this equation, we have two unknowns, the radius and the mass. For now, let's not worry about the unknowns and let's set up an equation for mass. So, for this problem, we're going to start with net force equals mass times acceleration. Now we know there's only one force, so the net force is just Fg, and we know that it's in a circular orbit, so we can replace acceleration with centripetal acceleration, or A sub c. Now, once again, we can substitute even further because we don't know centripetal acceleration with v squared over r. From there, we can plug in the equation for Fg, which is a gravitational constant g, times both masses. In this case, they're the same, so m times m over 2r squared, because they are both the same distance and have the same radius from the center, equals to the mass times v squared over r. Right now, we can cancel out one of the masses, and we can also cancel out one of the r's once it gets squared. From there, we'll rearrange through algebra to find that an equation for mass that reads mass is equal to 4v squared times r over g, or the gravitational constant. Now we have two unknowns in our equation, and we either need to find a way to substitute in for radius or mass. Well, we're looking for mass, so we know we need to find a way to substitute in for the radius. We can do this by using the equation period equals 2 pi times the radius over the velocity. Then we can rewrite the equation to solve for the radius. R equals v times t over 2 pi. Now we can only use this equation because it is a circular orbit. So, now though, we have the radius equals v times t over 2 pi, and we can substitute that into our equation. Once we substitute in, we can then reduce. So, after we substitute in and reduce, we have the equation mass equals 2 times the velocity cubed times the period over pi times the gravitational constant. From there, we plug in all the converted values that we were given, and we plug in the constant and put it in our calculator. Then we get mass equals 5.03285 times 10 to the 31st kilograms. I recommend not rounding here because we're not done with the problem yet and we want to be as exact as possible. From there, we need to convert into solar masses. So we'll take that mass we just solved for and put 1 solar mass over 1.99 times 10 to the 30th kilograms, or the mass of the sun. Once we plug that into our calculator, we get 25.29 solar masses. So, that's our problem. I hope you learned a lot from this. For me personally, what I struggled with was recognizing that since it is a circular orbit, we can use that the period is equal to 2 pi r over v to substitute in for one of our unknowns. From there, I was much better once I canceled, got all of our variables and quantities that were given to us or that are constant, and from there solving. I hope you learned a lot from this, and I hope you learned to recognize how to plug stuff in better, just like I did from this video. Have a great day.